Alright, so here we are, section 7.1, gas pressures. From our gases chapter, this is one of the most tremendous chapters that will cover this entire book. What we're going to be learning about is, well, a number of different characteristics of gases. So properties of gases. Matter occurs in three different states. We already know that. Solids, liquids, and gases. We talked about them a little bit. A gas does not have a definite volume. A gas is going to expand to fill the entire volume of its container. So if you think about, I like drawing cubes. I'm really good at drawing cubes. So here's a cube. Okay, so if you put, let's say, a penny, let's say you have a copper penny, then let's say that it's 1 gram. That solid is going to just sit right there. Okay, in that container. Now if you heat it up and you convert it from a solid to a liquid, maybe it's gonna, spill out a little bit, or it's going to, change its area that it occupies. And then if you compare that to a gas, like if you vaporize that liquid, well then it's gonna fill that container. Gas particles are extremely far apart. Gases have much lower densities than solids and liquids. So all the particles are very, very far apart. Hence, they are dense. Gas particles are in constant motion and collide with each other and with any surfaces in contact with the gas sample. Pressure. Now, when a gas particle strikes a surface, it exerts a force against that surface. Pressure is force per unit area. And so gas pressure is the sum of all the force exerted by gas particles impacting the surface divided by the area of that surface. This right here, this piece of instrumentation, this piece of glassware is known as a barometer or a barometer. Barometer is the proper pronunciation. This type of barometer is a glass tube filled with liquid mercury. Okay, now one thing that I'd like you to recognize about this is that this end of the barometer, well, it doesn't have an opening. Okay, now if you look down here, you've got a pool of this liquid mercury, and then the bottom of this tube right here, well, it has an opening that opens into that mercury. So what's going to happen is the force that is exerted by gas particles onto this surface of the mercury is going to cause the mercury to fill this chamber right here. And so what that is going to mean is that the height of this mercury in this evacuated chamber, well, it's going to change. It's going to change based on whether or not there's a large amount of air pressure forced down on that mercury pool or not quite so much. So the height of this column of mercury in this tube is the atmospheric pressure. So that H right here is equal to the atmospheric pressure. Now the units of pressure, one that we kind of toggle between back and forth is, or between, I guess, sort of three of them, is millimeters mercury and torr. Those conversions are super easy. 1 torr is equal to 1 millimeter mercury. Now another of the three that you have to really kind of keep track of is this guy right here. 1 atmosphere is equal to 760 torr, which, well, 760 torr is equal to 760 millimeters mercury. Therefore, 1 atmosphere is equal to 760 millimeters torr, 760 millimeters mercury. Pascal and bar, we don't use those quite so often, but you might see them on some of your homework problems. 1 atmosphere is equal to 1.012 or 1.01325 times 105 pascals is equal to 101.325 kilopascals. 1 bar is equal to 100 kilopascals, which is equal to 1,000 millibars. Like I said, though, these three are the ones that you're going to see most often. These you're probably going to see on homework questions, not necessarily quiz questions or test questions. Now an example, we want to be able to convert 648 torr to atmosphere. This one's pretty straightforward and easy. You got to know that conversion, 648 torr Our conversion factor is 760 torr is 1 atmosphere. Plug that in. Got a calculator floating around here somewhere, right here. 648 divided by 760 equals 0.853 atmospheres. Donezo. Okay. Convert 105 kilopascals to atmospheres. Okay, so this one's going to be a little bit different. What we're working with is 105 kPa. Well, 101.325 kPa is 1 atmosphere. So 105 divided by 101.325 equals 1.036. I can call that 1.04 atmospheres. All right, well, that wraps it up for this introductory section. It's going to involve a couple more things as we progress through this chapter, but you got this. You're good. Let's keep on rocking and rolling.